Okay, so in this video I'm going to look at calculating probabilities using the standard normal distribution table. So we've got a variable here called z, and it's a random variable with standard normal distribution, and we want to find these probabilities here. It starts off with a fairly basic one and works up to a kind of a combined one here, if you like. So let's have a look at how we work out these probabilities. So number one here is find the probability that our z value is going to be less than or equal to 1.75. Okay, so it's a good idea in these questions to actually just draw a rough sketch of the area of the curve that you're actually talking about. So just draw a rough standard normal curve. So we'll have a mean here of 0. 1.75 is going to be here somewhere, 1.75, and we're looking for z to be less than or equal to 1.75, less than or equal to 1.75. So in other words, we're looking for this area of the curve here. Okay, so in order to do this, our table will actually read only positive values. In our maths tables anyway, in our log tables, it will only read positive values, and it will read the probability that z is less than or equal to that particular z value. So what we've got to do is just take 1.75, which is here, 1.7, 1.7, 1.71, 1.72, 1.73, 1.74, 1.75. Decimal places are read from here. So 1.75 is 0.9599. 0.9599. In other words, 95.99% of our z values will lie down here in this part of the curve here. Okay, so let's look at question 2. Question 2, we need to find the probability that z will be greater than 0.93. Now remember, our tables will not read greater than, it will read less than. So we've got to work out how we're going to do this. It'll read positive values. This is a positive value, so that's perfect. So let's just draw a little curve here first. So this is our standard normal curve again, and this time we've got this is 0 here, and this is our 0.93. Now in this case, z has to be greater than or equal to 0.93. So in other words, we want this part of the curve here. Now our table won't read that. Our table, if we read 0.93 from our table, it will give us the probability of being in this part of the curve here, less than or equal to 0.93. Now underneath the curve, the probability of being underneath the curve is 1. So in other words, if we just do 1 minus the probability of z being less than or equal to 0.93, z being less than 0.93 is down here, subtract that from 1 and it will give us this value here, the probability of being under this part of the curve. So let's just read 0.93 from our table. 0.9, 0.91, 0.92, 0.93. 0.93 is 0.8238. 0.8238. 0.8238. We want 1 minus 0.8238. So that will give us 0.1762. So in other words, 17.62% of the data points on our original distribution, normal distribution, will be up here. Or 17.62% of the z scores will be up here, z values will be up here. Okay, so that's question 2. Let's have a look at question 3 then. Now, question 3 wants us to calculate the probability that z will be less than or equal to minus 1.23. Okay, now as I said earlier, our table will only read positive values, but we have a negative value here. It'll read less than, okay, but it won't read negative values. So let's see how we're going to deal with this. Again, let's just draw the area of the curve that we're actually talking about. So we'll just draw a normal curve here again. And we've got 0 here. We've got minus 1.23 this time. So minus 1.23 is here. and we're looking for less than or equal to minus 1.23. So we want this area of the curve here. Okay, so let's see how we're going to work this out. Now, the problem here is that, yes, our table will read less than, but it won't read negative values. So we've got to convert this to a positive value first. So I'm going to talk about 1.23 plus 1.23 here. Plus 1.23 is this area under the curve here. The area under the curve here is going to be exactly the same as the area under the curve here because this graph is symmetrical. It's a normal curve, so it's symmetrical, bell-shaped curve. So these two areas are going to be the same. So if we can find the probability of being in this area here, it's going to be exactly the same as this probability here. So let's see if we can work this out. This really is exactly the same as what we did up here. We need to find the probability of z being less than 1.23, which will give us all of this area here. Then subtract it from 1, which will give us this the probability of being here, which is exactly the same as the probability of being here. Okay, so really what we need to do, this thing here is going to be just exactly the same as the probability, or it's going to actually be 1 minus the probability that z will be less than or equal to 1.23. So if we can calculate this, it will give us the probability of being less than or equal to minus 1.23. So let's do this then. Okay, so we need to read 1.23 from our table. 1.2 is here, that's 1.2, 1.21, 1.22, 1.23, which is 0.8907. Okay, so it's 0.8907. So that's just simply equal to 0.1093, or 10.93% of our data points in our original normal distribution will be down here. Okay, so the probability that our z values will be less than or equal to minus 1.23 is 0.1093, quite a low probability. Okay, excuse me. Now let's have a look at question 4. Now, question 4, let me just remind myself what it was again. So it's the probability that z is greater than or equal to 1.2 and less than or equal to 0.72. So let's write that out down here. Okay, so we want the probability that z will be greater than or equal to minus 1.2, less than or equal to 0.72. Okay, so again we're just going to draw a normal curve here. So we'll just, our standard normal curve rather, so we're just going to go up, down here, we're going to put in our mean again of 0. Now we want to look at the points between minus 1.2, so we'll say that's here, minus 1.2, and we want 0.72, let's say that's here somewhere, 0.72. So really what we want to do is find the probability of our z values being somewhere in this area here. Okay, so let's see how we're going to work this out. Now, to find this probability here, what we're going to do effectively is our overall strategy will be to find the probability of z being less than 0.72, which is all of this area here, including this bit here, all of this area here. Our tables will read that for us directly, and then we're going to subtract the probability of z being less than minus 1.2. We're going to subtract this area here. So we're going to find this area, if you like, and then subtract this area to give us this red area in the middle here. Okay, so really what we want to do is find the probability that z is going to be less than or equal to 0.72. That's all of this area here. Then we're going to subtract the probability that z is less than or equal to minus 1.2. Okay, we can do this directly from the tables, that's no problem. this is positive and this is less than or equal to, so that's fine, we can just read it directly. However, on this, in this probability here, we've got less than or equal to, that's fine, but we've got a negative number here. Now, as in the previous example, this here really is this area here. Now, in order to find this area here, the probability of being in this area here, what we're really going to have to do is, I'll just draw another quick curve here. Whoops, not a very nice one, but there you go. 0, and this is my minus 1.2 here. So really, this part here of our problem is down here. Now again, as with the previous question, we can't do this. So because our graph is at least supposed to be symmetrical, I know mine doesn't look too good, but we're just going to find the area of being up here, find the probability of being in this area here. And to find this, we need to just read 1.2 from our tables. That will give us all of this area down here, the probability of being in this area here. Subtract that from 1, it'll give us the probability of being up here, which is the same as the probability of being down here. So really all of this will turn into the probability of z being less than or equal to 0.72 minus 1 minus the probability of z being less than or equal to plus 1.2. So really this is what we have to work out effectively. Okay, so let's see if we can work all of this out. Now, first of all, I'm going to read z being less than or equal to 0.72. So let's see if I can get that. 0.72. So 0.7, 0.71, 0.72. That's 0.7642. 0.7642. So that's 0.7642 minus 1 minus the probability of z being less than or equal to 1.2. So let's look for 1.2. So 1.2 is here. This is 1.2, 0.8849. 0.8849. So this is 0.8849. Okay, so now we just need to do 0.7642 minus 1, and then minus here is plus 0.8849. So we can do this on our calculators or whatever way you like to do it, and the final result for that will be 0.6491. 0.6491. Okay, so in other words, 64.91% of our data points, or our z values in this case, will be in this red area here. Okay, and that's it for that question. Now, just to do one final question, I'm just going to do a kind of a practical question, if you like, and it involves the heights of students in a certain class. Let's say the heights of students in a certain class are normally distributed. So they're normally distributed and they've got a mean of 165 centimeters and they've got a standard deviation of 10 centimeters. Okay, so they're normally distributed with a mean of 165 centimeters and a standard deviation of 10 centimeters. If a student is chosen at random, so you pick a student at random, find the probability that the student's height is less than 170 centimeters. So we're looking for the probability that our x value, our student, will be less than 170 centimeters. So we want the probability that if we pick a student at random from this particular class, measure his height or her height, that they will have a height less than 170 centimeters. Now, first of all, when we talk about normal distributions, less than and less than or equal are effectively the same thing. So you don't worry about whether there's a less than or a less than or equal. It's the same procedure. So if we were to draw this curve, we've basically got, we're talking heights here. So again, we would have a normal curve, and in this case, we know that our average or our mean here is 165 centimeters, and we've got a standard deviation of 10 centimeters. So in this particular case, we've got an x value, we've got an actual height here, so we've got to convert that first of all to a z value in order to work out the probability. This x value here is actually 170, so let's say it's here, that's 170, and we want the probability that x is going to be less than that. So we picked a student at random. What's the probability that student will lie, his or her height will lie down here somewhere, will be somewhere down around here. So first of all, we've got to convert this x value to a z value. So in order to do that, we use the formula, if you like, our x value minus our mean. This is our mean here. Sorry, this is our mean here. This is mean, and this is our standard deviation here. So standard deviation divided by standard deviation. So our x value here that we're talking about is 170. We want to see how far that is from the mean. Our mean is 165. How many standard deviations is that? Well, we divide standard deviations into it to see how many standard deviations 170 is from our mean. So when you calculate that, you get 0.5. 0.5. Okay, so really what we're looking for is the probability that our z value will be less than 0.5. This we can read from the table. If we can find the probability that our z value here is less than 0.5, that's exactly the same as our probability that our any x value will be less than 170 centimeters. So let's just read this from our tables then. Let's look for 0.5. So 0.5 is here, which is 0.6915. 0.6915. 0.6915. So the probability that our z value is less than 0.5 is 0.6915. In other words, the probability that if we pick a student at random, his or her height will be less than 170 centimeters. It will lie down here somewhere. Or you can look at it, you can say that 69.15% of our heights are in this part of the curve here.